Well, welcome back for 4.2, which is going to be about the unit circle. I'm not sure how you did on your 4.1 with your productive struggling, but we're going to continue to do some productive struggling because we're still in the phase of this chapter where we're learning a lot about some different definitions and some new terminology and just a new way of thinking about doing trigonometry with using a circle, so that then we can move into what we call the periodic functions. So for this lesson, you should have a white note card that I gave you in class that has a circle drawn on it, similar to what's on the screen here as you're watching this video. If you don't have that, you'll need to get a piece of paper and draw a circle on it, or you'll need to get another note card and draw a fairly large size circle on that note card, about the same size as the note card, not quite as big as the note card, so that you can take a lot of notes and make a note card about the unit circle. We'll use this note card over and over and over again for many, many things. We may eventually need our calculator today, our graphing calculator, when we get our video notes going, and then you'll need that sheet of video notes for lesson 2A. So I'll give you a chance to stop the video and gather up all those things because we'll be using them here in just a minute. Alright, if you have all of those things, I think we'll be ready to proceed. Okay, we're going to start by talking about the unit circle and what this really means. A unit circle is defined to be a circle that has a radius of a unit, which could be one whatever. Could be 1 centimeter, 1 inch, 1 mile, 1 meter, 1 whatever. We're just going to call it a circle with a radius of 1. And since they call it 1 unit, then they call it the unit circle. Alright, so I want you to take the circle that's on your note card and a straight edge, and I want you to pick out where you think the center of that circle is, and then use that straight edge to draw a set of axes on here so that we are cutting the circle in half vertically and horizontally. And then I'm going to put some arrows on the ends here, so that I'm indicating that I have put this or placed this on the coordinate plane. Alright, I am going to identify this center point of my circle as the point 0, 0. Alright, so my circle now is drawn in quadrants 1, 2, 3, and 4, and I would like for you to label those quadrants 1, 2, 3, and 4. And they're labeled exactly how they're labeled in algebra class. So we'll just kind of draw them on there going in a counterclockwise motion. Alright, what we're going to do when we think about working with the unit circle, if I were to draw some angle here, I'll call my angle theta, and I'm going to take that theta to go in the counterclockwise direction. So I call this a rotation through the amount of theta, rotation through theta, of this point right here. If I'm on a unit circle such that this radius is 1 right here, then this is the point 1, comma 0, isn't it? 1, comma 0? Okay, what would be the point at the top here? Well, it would be the point 0, comma 1, wouldn't it? Over here, this would be the point negative 1, 0. And down here at the bottom, this would be the point 0, negative 1. So if I'm fitting this on a coordinate plane, I have these points. That would be the endpoints of the diameters right there on the axes that I've drawn. So I would have 1 unit from 0, 0 up to this point, 1 unit here, 1 unit going down, 1 unit going to the right. Okay, in terms of the measure of this angle right here, this is 0 degrees, and it's also 0 radians, isn't it? At the top up here, we're at 90 degrees, which is pi over 2 in radians, right? Over here we're at 180 degrees, which remember is pi radians. And down here at the bottom we are at 270 degrees, which is 3/2 pi in radians. A little equal sign there. And then if we go all the way back around to here, we'd be at 360 degrees, which equals 2 pi in radians, doesn't it? Okay, if at any time you're not able to keep up with what I'm writing on the unit circle here, then you need to stop or pause the video so that you make sure you get all the notations on there that I have on here. So right now, you should have everything I have, including the endpoints of the diameter, here, what they are in terms of the coordinates, and then all the radian and degree measures, as well as the quadrants. Okay? Now what we're going to think of doing here is taking this theta that we marked off here and rotating this point up to some point right here. So I don't know if that's a 50-degree angle or a 45-degree angle or a 52-degree angle or a 49-degree angle. I don't know what the angle measure is. I'm just rotating it to some theta amount. Okay? And when I do, when I get that over there, the coordinates of this point are going to be the cosine of theta, comma, the sine of theta. The cosine and then the sine. I want you to write that on there. And when you get that written on there, I'm going to show you on another circle that you're not going to write on yours why that ordered pair is the cosine of theta and then the sine of theta. Okay? So let me buzz down here to another circle that I happen to have drawn on here. And let me draw some new axes on here. And again, this is the 1 for my unit circle. Let me put that angle on here again, this angle theta. So I'm going to take the point 1, 0, and I'm going to rotate it up here to some coordinates that I don't know. But let me do this. Let me drop a right triangle down here, something you are familiar with. Okay? If I do that, then the distance from here to here is not 1, it's less than 1, isn't it? I don't really know what it is. I really don't know what this distance is right here either, do I? But I know that this is 1, don't I? I know that that amount is 1 because that's a radius. From here to here is a radius, isn't it? And so if I was trying to figure out what those coordinates are, what I could do is I could solve for them. All right? I don't know which one you want to call what, but we'll call this one x and we'll call this one y. So this will be x over and it'll be y up. So this distance will be x over and this distance will be y up. Okay, if I'm looking at solving back with SOHCAHTOA, then I would be saying that from this reference angle right here, this is my opposite and this is my adjacent, isn't it? That's my opposite and that's my adjacent. So I could say that the sine of theta is opposite over hypotenuse, isn't it? Okay, well this is theta. The opposite would be the y over 1, wouldn't it? Y over 1. So the sine of theta is equal to my y amount, which should make sense because that's how high up I'm going to go on the y, isn't it? Alright, if I do the cosine of theta, the cosine of theta is adjacent over hypotenuse. That's this length of x right here over 1. Well, x over 1 would just give me cosine theta is equal to x. So if my ordered pair is x comma y, then my ordered pair would be cosine theta sine theta. So the coordinates of this point right here would be cosine theta sine theta. That's what it would be. How far over am I? Well, I'm cosine over. How high up am I? I'm sine up. Okay? So cosine over and sine up. And that's based back on the right triangle from SOHCAHTOA. So that can be very confusing for students when they first start out working with trigonometry, because you always like to do sine first and cosine second. In fact, look on your calculator. What button comes first? The sine button and then the cosine button. So everybody probably thinks, well, the cosine comes before the sine. Well, actually, cosine, the word cosine stands for the complement of the sine. And so complement of the sine goes with the sine. They go together. But the coordinates of that point are cosine theta, sine theta, which is kind of neat because that happens to be your x, comma, y. So if somebody gives you the coordinates of an ordered pair that are from the unit circle, then you would know the cosine of theta is the x value and the sine of theta is the y value. So we're going to use that in just a little bit to solve for some of these ordered pairs that we wrote on here, these easy ordered pairs that we wrote on here. All right? Now, another thing you're going to notice is that when you're in the first quadrant, all of the ordered pairs are positive, positive. Isn't it true that we go so far over to the right and then so far up, so the ordered pairs in the first quadrant, the coordinates of x and y are both positive? In the second quadrant, we go negative and then positive. So I'm going to write that on there, negative and then positive. In the third quadrant, we go negative and then down. So the third quadrant, we're at negative, negative. And in the fourth quadrant, we go over and then we go down. So we're from positive to negative, positive x's and negative y's, right? And so that's also going to be important for us because if we notice the ordered pairs they give us and we see that we have a negative, negative, if both coordinates are negative, then we're going to know we're in the third quadrant. And in the third quadrant, we'd know what the radian measures are and what the angle measures are in degrees. If we got coordinates that were, say, positive and then negative, we'd know we were in the fourth quadrant. Okay? Now, we haven't talked about tangents, how tangents fit into this. And the tangent in trigonometry, you know tangent to be opposite over adjacent, don't you? Opposite over adjacent. But we can't use that as an idea here because opposite over adjacent wouldn't really help us, would it? So we're going to define tangent. And this is going to be a new definition for you, so make sure we write this on your note card. The tangent of theta, the tangent of theta okay, try this again. Tangent of theta is going to be defined as the sine of theta divided by the cosine of theta. So this is a new definition for you. It will be sine over cosine. I want to make sure you know that it's the sine over the cosine. So we could figure out what the SIGN sign, whether it's positive or negative, for tangent. If we say, well, it's positive divided by a negative, then your tangents are going to be positive, aren't they? Since this represents the sine and this represents the cosine, sine over cosine in the second quadrant means that tangent will be negative. Down here, negative sine, negative cosine, negative divided by a negative means that tangent will be a positive. And over here, sine is negative, cosine is positive, and negative divided by positive gives us a tangent that is a negative. And now you notice that when I talk about sine, S-I-N-E, sine, sine is positive in the first quadrant and the second quadrant, and it's negative in the third quadrant and the fourth quadrant, isn't it? Cosine is positive in the first quadrant and positive in the fourth quadrant. It's negative in the second and negative in the third. Tangent is positive in the first, positive in the third, negative in the second, and negative in the fourth. And so there's a little acronym that you can learn to help tell you where things are positive and where they're negative, okay? And it goes like this. I'm going to write it on here in black, okay? It says, all students take calculus. This means that in the first quadrant, all of your functions, sine, cosine, and tangent, are positive. S is going to stand for sine. In the second quadrant, the only thing that's positive is sine theta. T, the take, and T, it stands for tangent. The only thing positive in the third quadrant is tangent. And calculus fourth quadrant, the only thing positive in the fourth quadrant is the cosine. So you know if you have those ordered pairs and you can identify that the sine is negative, the cosine is negative, and the tangent is positive, then you know you're in the third quadrant. Okay? So you can use that little acronym. All students take calculus in order to figure that out. Okay, so this brings us to how powerful the unit circle is and how great it is for figuring out the sine and the cosine and the tangent of the numbers right here on the end point. I'm going to darken these in black so we can talk about these in black. Okay? If I start out at 0 degrees, and I see this 1 right here, 1 stands for the cosine. So what should the cosine of 0 degrees be? It should be 1. Now I'm going to take my calculator, and I'm going to check my mode, and I'm going to make sure my mode is in degrees. My mode is in degrees. You need to change yours. Just put your cursor on top of here and click that to choose it. Okay, now I'm going to show you that the cosine of 0 degrees is 1. Okay, what should the sine of 0 degrees be? Well, the ordered pair is 1, 0, where sine, the y-coordinate is sine. So the sine of 0 degrees should be 0. All right? What would we get for the tangent of 0 degrees? Well, if I divided 0 by 1, 0 divided by 1 should give me 0. So the tangent of 0 degrees should be 0. All right, let's go up the ladder here a little ways to 90 degrees. 90 degrees is the ordered pair 0, 1. That means the cosine value is 0 and the sine value is 1, because remember the ordered pair goes cosine and then sine. So if I type in the cosine of 90, that's for cosine first. The cosine of 90, the cosine of 90 should be 0. Okay? The cosine, or the sine of 90 should be how much? Should be 1. Now, for the tangent here, I'm going to have sine divided by cosine. Remember that formula, sine divided by cosine? 1 divided by 0. So if I put in the tangent of 90 degrees, what's dividing by 0 give us? Gives us an error in the domain. Okay? Sends you back to the 90 part, saying the argument of this function causes you to have a 0 in the denominator. So this will be undefined. The tangent of 90 would be undefined. Now, I shouldn't need a calculator for the rest of these. I'm just using the calculator to verify. So, what is the cosine of 180? The cosine of 180 should be -1, right? The sine of 180 should be, let's say the cosine again. The sine of 180 should be this component of my ordered pair. It should be 0. The tangent of 180, 0 divided by -1, should give us 0, and it does. What should the cosine of 270 be? It's going to be 0. What is the sine of 270? 270. It should be -1. And now, again, if I take the sine divided by the cosine, -1 divided by 0 should be undefined. So the tangent of 270 is going to give us an error in the domain. It's undefined again. Then I could go right up here to 360, where the cosine is 1, and the sine of 360, where that would give me a 0. Okay, so you should be able to take those ordered pairs and be able to really rattle these off. I could go around the circle either clockwise or counterclockwise, wind up at those endpoints, and you should be able to tell what those amounts are. So for instance, the sine of 180 would be the y component. It would be 0. The cosine of 270, the x component, it would be 0. The tangent of 90, 1 divided by 0, gives me undefined. If I said the sine of -90, you would go down your card clockwise. The sine would be -1. The cosine of -180 would send us over here 180 in the clockwise direction. The cosine would be -1. what's the tangent of 0 degrees? Our sine divided by cosine would give us 0. Alright, so you should be able to go around that unit circle either clockwise or counterclockwise and very quickly be able to figure out all the different amounts. Now they could also give us those amounts in radians. They could say, what's the sine of pi over 2? Pi over 2 is up here, sine is 1. What if they said the sine of 5 pi? Well, you could count off your pi. You could say, well, here's 1 pi, 2 pi, 3 pi, go back around here to 4 pi, and then to 5 pi. The sine of 5 pi would be 0. The sine of negative 3/4 pi, I go around my circle 3/4 of the way. The sine of negative 3/4 pi would be 1. So at least for a while when you're first starting to learn about the unit circle and these measurements, that card would be very, very helpful to you in determining that. Okay? There are a multitude of other places along in between these 4 endpoints that will give us different measures, and they will be decimal amounts. Some of them represent rational numbers, some of them represent irrational numbers, mostly irrational numbers. So you'll find a lot of them are not going to come out very nicely, but there are some that there's a pattern to them. Okay, now that we have our note card pretty well filled out, what we're going to do is we're going to use that note card to help us do the video notes over for lesson 4.2. So I want you to bring up your video notes next. And then I want you to attempt to use your note card, your unit circle note card, to fill in these exact amounts for problem number 1. If you could take just a couple of minutes, you'll want to pause the video, and then you'll want to go through here, do 270, you're going to do negative 3 pi, and you're going to do 0. That's not 0 degrees, this is 0 radians, because that's not got any label on it. The 0 radians is the same as 0 degrees as far as the unit circle note card. So use your unit circle note card and see if you can get them filled in. You can pause the video and do that. Okay, did you come up with what I came up with here? If I draw my circle on here, 270 degrees would put us around to here, to the ordered pair 0, negative 1, where the sine would be negative 1, the cosine would be 0, and dividing would give me undefined. Negative 3 pi, change color here, there'd be negative 3 pi. So here's negative 1 pi, 2 pi, 3 pi. That would take you around to this ordered pair, which is negative 1, 0. The sine is 0, the cosine is negative 1, the tangent is 0, isn't it? And 0 right here is the ordered pair 1, 0, where the sine is 0, the cosine is 1, and the tangent is 0. If you got all those, good job. You should not have to use your calculator to find them. Okay, in 4A and 4B, the coordinates of the indicated image, we're going to find those coordinates and we're going to round them to the nearest thousandth. Okay, and so they want us to do a rotation of 48 degrees. A rotation of 48 degrees. So let me get a circle on here. And I'm going to rotate 48 degrees. Notice that on the unit circle, they always start 0 over here because it coordinates with the point 1, 0. It also, think of it as coordinating with 0 degrees, where this would be the top half of your protractor. So 48 degrees might look about like this. I'll make this be theta, and I'll say theta is 48 degrees. Okay? We want to know the coordinates of that point right there. Well, I don't know the coordinates of that point right there off the top of my head because it doesn't land on something where I have, you know, right here I have 1, 0, and here I have 0, 1, and so on. I know that the cosine component is between 1 and 0, and I know the sine component is between 0 and 1. But I do know that this represents cosine theta, sine theta. And so since theta is 48, it represents exactly the cosine of 48 degrees, the sine of 48 degrees, doesn't it? Because that's what theta is. It's 48 degrees. Now, what I'm going to do with that is I'm going to take my calculator and I'm going to figure out, well, how much is that? So my calculator is set in degrees, right? And I'm going to clear this out. And I'm going to go to cosine of 48. That's my x component, cosine 48. And it is 0.669. It says to the nearest thousand, so to 3 decimal places. Okay, I'm going to put squiggly lines out front here. 0.669. Now, does that fit in the pattern? Should it be between 0 and 1? Yes, it should be. And now I'm going to do the sine of 48 degrees. 0.743. So then this will be comma 0.743. So that's the actual ordered pair. That would be the cosine of 48 degrees. All right? Now, notice on 4B, they're asking you to do 1.6. Well, what is 1.6? 1.6 is in radians, isn't it? 1.6. So where would that be on your circle? Where would 1.6 be on the circle? Now, let me draw a circle on this so we can figure it out. Okay, I know if I went all the way over to here, this would be 3.14 about, wouldn't it? So 1.6, half of 3.14 is 1.5, so it's a little bit past this, isn't it? This is half of 3.14, so that's about 1.57. So I want 1.6, so 1.6 is going to be just about right here. Okay? This theta right here is going to be 1.6 in radians. Alright? Well, what I know about that is that this is going to be the ordered pair cosine 1.6, sine 1.6. So cosine 1.6, since that's what theta is, this is our theta down here, and then the sine of 1.6. Alright, well I'm going to have to change my calculator out to radians in order to do this problem. Okay, I'm going to go to my mode, change this to radians, and I'm going to get the cosine of 1.6. Cosine is to 3 decimal places, negative 0.029. Okay, let's see if that would be right. Should it be a negative? Well, if I go over so far to the left, this is past 90, I would be, let's get my axes on here, I would be in quadrant 2, wouldn't I? So cosine will be negative and sine will be positive. Okay, I forgot what it was. Negative 0.029. Negative 0.029. Okay, if I want to know the y-coordinate, that's the sine, and that's the sine of 1.6 radians, and it would be 0.99957. So how do you want to round that to 3 decimal places? We'd have to call that 1.000, wouldn't we? So it's really, really close up here. I probably drew my picture a little off because it's really, really close to the 0,1 point, isn't it? Okay, and that's a 0, not a 6. Okay, how could you tell the signs of the coordinates for 4A and 4B without using your calculator and just using your circular, or just using your unit circular? Well, you know that 48 degrees is where? It's in quadrant 1, isn't it? Okay? Where both the cosine and the sine are positive, aren't they? In this first quadrant, everything's positive. Sine, cosine, and tangent, right? Okay. 1.6 radians. You know, and another thing we could have done is we could have taken those 1.6 radians and we could have multiplied by 180 and divided by pi, and we could have come up with an angle measure. It's 91.67 degrees, so just a hair past 90 into that second quadrant, barely into that second quadrant. Okay? Well, that is in quadrant what? 2. Okay? And that's where cosine is negative and sine sine is positive. So it makes sense what we got for our ordered pairs because we're in quadrant 1 here, we're in quadrant 2 here. Okay, now on problems 5 to 8, they're going to ask us to use our unit circle note card again. And so I'm going to draw a pretty good sized circle here and just kind of mirror image. You can get yours out. I can't have both things open at the same time. What I really need to know, these are my quadrants, 1, 2, 3, 4. Okay, and then remember that everything in the first quadrant, cosine and sine are positive, tangent is positive. In the second quadrant, cosine is negative, sine is positive, tangent is negative. In the third quadrant, cosine is negative, sine is negative, tangent is positive. In the fourth quadrant, cosine is positive, tangent is negative, and sine is negative, and then the tangent is also negative. Okay, when they write this, they're wanting us to describe all the values of theta between 0 and 2 pi, which means the answers that we're going to get are going to be in radians. So we may want to mark this as 0 radians, pi over 2, pi, 3/2 pi, and back to 2 pi, so we can keep track of the fact that we're going to be doing this in radians. And they need to satisfy these requirements. Well, these requirements look kind of more algebraic with the less than and greater than signs in there, but you need to think of these as referring to whether or not these are positive or negative. If the cosine is less than 0, that means the cosine is negative. If the sine is greater than 0, that means the sine is positive. So you'd want to go where the cosine is negative and the sine is positive. Well, what quadrant would that be in? Well, right here, where we have negative cosine and positive sine. So this is in quadrant number 2. Now they want you to write the interval that would take up all of the values where all of the cosine values are negative and all the sine values are positive. So in other words, they want us to write an expression for, colored along here, this whole entire black region right here. Okay? Alright, well, we're going to write that as an interval. We're going to say it starts at pi over 2 and it ends at pi. That's where that quadrant starts. We don't want to use the endpoints, though, because at the endpoints we have the numbers 1 and we have 0. So we don't really want to use those endpoints. So we're going to use parentheses. Okay, let's try number 6. This is saying where is sine negative and tangent negative? Where is sine negative and tangent negative? Well, sine and tangent are negative in quadrant number 4. Quadrant 4 starts here and ends here, doesn't it? Okay? So it starts at 3/2 pi. When you're on these endpoints, you're not really in any of the quadrants. It's just past 3/2 pi, and it ends at 2 pi. And again, we have parentheses. Okay? Where does the sine equal 0? Where does the sine equal 0? And where is the cosine positive? Okay. Sine equals 0. Can you think of that? Where does sine equal 0? Well, this is the ordered pair, 1, 0. Here's the ordered pair, 0, 1. Here's negative 1, 0. And here is 0, negative 1. So, sine is equal to 0. Sine is equal to 0 at 0 and again at pi, isn't it? At 0 and at pi. Okay, we want to know where's your cosine positive. Well, the cosine in this one is negative, cosine for this one is positive. So it needs to be at 0. Now notice that's not an interval, and that's because this is a specific value that they're having you pick out. Okay, when it says tangent theta is less than 0, that's where tangent is negative. Cosine theta less than 0, that's where cosine is also negative. So where is cosine negative and where is tangent negative? That's going to be in quadrant 3, right here. Cosine and tangent are both negative. Quadrant 3 starts at pi over 2, and it goes to pi. There you go. Okay, so you kind of have to decode those a little bit, but you'll have some really good video notes to help you out with your homework when you get to those problems on your homework. Okay, and last but not least, it wants to know if you can refer to this unit circle shown, which letter best represents the value given. Okay, remember in the ordered pairs, this will be the cosine component, and this will be the sine component. They want to know about the sine of negative 270. We're going to start here at 0 degrees and 0 radians. Okay, so you would go over to negative 270, which is clockwise, 270 degrees. You would be at this ordered pair, which is C comma D, and there you want to pick the component that matches the sine, and that component would be the second coordinate, which is letter D. Okay, how about 13/12 pi? 13/12 pi. Well, first of all, you know you're going to go counterclockwise because it's positive. 12/12 pi is 1 pi, isn't it? Which is right over here. I go 1 pi in this direction. If I want to go a little bit past 1 pi in the counterclockwise direction, I'm going to wind up at this ordered pair G comma H, aren't I? I want the cosine component. The cosine component would be letter G. And the first component of the ordered pair is cosine. They go in alphabetical order. Okay, how about the cosine of 135? Start at 0 degrees. I go 135 in the counterclockwise direction. That would put us at this ordered pair E comma F. I want the cosine component, so I'm going to take letter E on it. The sine of pi over 3. Pi over 3, do you know that one by now? Pi over 3 is like 180 degrees over 3. So that's 60 degrees, isn't it? It's equivalent to 60 degrees. So it's right here, just a little ways up. I want the sine component, so I want letter B. And negative 2/3 pi is going to send me in the clockwise direction. Negative 2/3 times 180 would give me negative 120 degrees. So it's right here at this ordered pair. I want the cosine component, so I want letter I. I want letter I. Okay. Hopefully those make sense to you. They don't want the whole ordered pair, they just want part of it. Okay. So the last part of this lesson is we're just going to embark upon our little journey on the Ferris wheel. In certain chapters, they tend to pick out certain types of problems that they like to revisit over and over and over again. Well, in this chapter, it's going to be the Ferris wheel, because the Ferris wheel has some really great properties to share in this particular lesson, and then some lessons coming down the way. It says, as of 2008, the largest Ferris wheel in North America is the Texas Star at the Fair Park in Dallas, Texas. Its seats hang from 44 spokes. This Ferris wheel is 212 feet tall. How high is the seat off the ground as you travel around the wheel? So that's what we want to investigate. To do this, we're going to have to make certain assumptions. Because when you get on the Ferris wheel, you're going to be at the wheel's lowest point. In other words, they're not going to take a cherry picker and raise you up and have you jump off and get on, you know, halfway up or at the tallest point or anything like that. You wait till the Ferris wheel comes around to the bottom, and then they let you on. You go up the little ramp and you get on the thing. Okay? So this is going to be what we call it ground level. Okay? Ground level. And that's going to be theoretical ground level. Okay? We want to assume that the seat is going to be the same distance directly below the end of the spoke the entire way around the Ferris wheel. Alright, so in other words, you have this Ferris wheel and you have this seat that's hanging down off of it. Okay, as you go up and up and up and up, that seat's going to hang down the same amount of space each time as it's hooked on. Okay, that's what they're saying. Okay, as you go round and round and round the Ferris wheel. Okay, you want to think of the Ferris wheel as a circle on a grid. The center of the wheel is the center of the circle, and it's at the origin. And in this case, the radius of the wheel, okay, well, let's think about this for a minute. We have 212 feet tall. So I've got a little picture down here for you. This is 212 feet of height, total height, so the radius is going to be half of that, which is going to be 106 feet, isn't it? Okay, so let's fill that in. This would be 106 feet. Okay? Which coordinate of the ordered pairs going around the wheel are going to give the height of the Ferris wheel? Well, if we think of that on our unit circle, draw my unit circle here. Go down to this one. Okay, this is the length. Oh my. Now we're getting fancy. This is the length, and this is the height, isn't it? So this y component is the height, and this is how far over. Okay, this is the horizontal distance, and this is the vertical distance, isn't it? Okay, so I go cosine over and sine up, don't I? Cosine over and sine up. So when I'm thinking about this, this will be the sine of theta, would be the distance up. So we're talking about in that unit circle, this component right here, this is the height. That's the sine. Cosine's here, sine is here. Remember, this ordered pair is cosine over and sine up. Okay, the Ferris wheel models the unit circle with a scale change of 106 because it doesn't have a radius of 1. It has a radius that's 106 times blown up or stretched or bigger than that. The height of the seat at any time is determined by the magnitude of rotation from the of the spoke from the what we're going to call horizontal. Okay, let me show you what that looks like. You're going to start here, and you're going to move it around, and it's going to go round and round and round from there. So instead of this being cosine 0 sine 0, this is 106 times the cosine of 0, comma 106 times the sine of 0, or not 0, but, well, yeah, 0. Not theta, but 0. Okay, so that's the ordered pair there. At the top, we'd be at 106 times, remember this ordered pair is 0, 1. Okay, so that would be the cosine of 90 degrees. And then we'd have, oops, it should say 160, it should say 106. And you'd have 106 times the sine of 90 degrees. Here, we'd be at the ordered pair negative 1, 0, but we're going to scale that. So we're at 106 times the cosine of 180 degrees, and then 106 times the sine of 180 degrees. And of course down here at the very bottom, if I drew this on here, coming down to the very bottom, this would represent 0, negative 1. So this would be 106 times the cosine of 270 degrees, 106 times the sine of 270 degrees. I'm going to put degree marks on those so we can remember that there's 0 degrees. Okay, and remember this distance from here to here, going down here, that'd be 106 feet, wouldn't it? Okay, it says back up here that, so in general, a seat that has been rotated theta in the Ferris wheel is going to go around this way in the counterclockwise direction from the ground. So you get in the Ferris wheel on the ground and you start going this way, don't you? And you make a counterclockwise motion, don't you? Okay? Is at a height given by the formula 106 times the sine of theta, whatever that is, plus 106. Since 0 is right here, it's like the circle is half of it's below ground and half of it's above ground, kind of. It'll all come out in the wash when we add on this 106 feet on the back end. Okay? The heights of the 44 seats on the Ferris wheel would follow a pattern. Okay, we want to know what pattern they would follow. Okay, well let's see if we can figure it out. Okay, well the seat at the bottom, that'd be this seat right down here at the very bottom, it's going to be at 106 times the sine of, and then you just need to tell what that amount is. Could we put 270 degrees in there? Yes. Could we put negative 90 degrees in there? Yes. Could we put 3/2 pi if we did radians? Yes. Could we put negative pi over 2? If we wanted to go radians going this way? And the answer to that is yes. So it could be any of those four measures right there plus 106, right? Now let's see how much that's going to be. Alright, since my calculator is in the mode for radians, I'll just do one of the radian ones, okay? I'll say it's 106 times the sine of, should we just go ahead and say 3/2 pi? I'll just use 3/2 pi. 3/2 pi plus 106. And sure enough, it's 0. But that's what it should be if we're at the bottom, okay? What about the seat on either side of the bottom? So that would be this one here or this one here, okay? The seat on either side of the bottom. Okay, now remember, did it tell how many we had? There were 44 spokes, right? 44 spokes? Okay, so if we wanted to figure this one out, we'd need to go, okay, let's figure this. The whole distance around our circle is 2 pi, and we're going to divide it up into 44 equal spokes. So that's pi over 22. Pi over 22. So if we were here and we went forward, this one would be at pi over 22. That's where that's going to be, pi over 22. Now, the other thing you can do is you could go, oh, that wouldn't be pi, because we're at where? We're at negative pi over 2? No, we're at 3/4. Okay, wait a minute. We're at 3/2 pi here. We'd have to add on pi over 22. 3/2 pi plus pi over 22. Wouldn't we? We used 3/2 pi here? Yeah, we did. Okay, so it would wind up being 106 times the sine of, I'm just going to write it in here and we can figure it out later, but it would be 3/2 pi plus, wouldn't that be plus? Yeah, because we're still going around counterclockwise. Pi over 22, okay, plus 106. Okay, well, let's try that. I'm going to get my calculator up here so I can keep it on here with everything else. Okay, so we'll say 106 times the sine of 3/2 pi plus pi over 22. Oops, I got E. Sorry. Pi over 22. Okay, and so we'll get the sine of that, and then we'll add another 106 on. Okay, so how far are we over? We're about, here, 1.08 feet, aren't we? We're about 1.08 feet off the ground if we're at that next stop over. Now we could go back the other way. Let's see what would happen if we went 106 times the sine of 3/2 pi minus pi over 22 plus 106. So let's change that. I'll go back in here and I'll change this to a minus. And we'll sit for the same spot. And sure enough we are, because we should be symmetrically the same distance above the ground, 1 feet behind and 1 feet ahead of that 0 height there, shouldn't we? Okay, it says what if we were 2 seats from the bottom? Well, 2 seats from the bottom would be 106 times the sine of 3/2 pi plus 2 times pi over 22, right? That's 106. We'll see if we can doctor this up and use this again. I'll change this back to a plus, and then I'll get a 2 on here. 2 times pi over 22, okay, says we are about 4.29 feet off the ground. So if we went over to this next spoke right here, okay, then this distance down to the ground here would be about 4.29. The distance here is only about 1.08 feet. Okay, so it's the seat at the top of the wheel. Now the seat at the top of the wheel, that's kind of interesting, the seat at the top of the wheel. We should be able to get that one without even really thinking about it. At the top of the wheel, that's a diameter, so how high off the ground should you be? You should be 212 feet, shouldn't you? Okay, if you did 106 times the sine of pi over 2, and then added 106, let's see what you get. 106 times the sine of pi divided by 2, and then adding 106 does indeed give you 212. Okay, now, this one's a little tricky. It says the seat rotated 3/4 pi from the horizontal. Okay, well, let's check this out. Here's the horizontal. Get a different color pen here. Here's the horizontal right here. We want to go 3/4, what did it say? 3/4 pi from there. Okay, 3/4 pi. So we want to go to 3/4 pi. Well, here's 1/2 pi over here, so, or 1 pi, so 3/4 of the way over to pi. So you'd want to go over to here, which is 3/4 pi. Okay, well that's being measured from 0, isn't it? It's being measured from 0, so we can just use that 3/4 pi in our calculation from the horizontal. Okay, so we're going to say it's 106 times the sine of 3/4 pi, okay, and then add our 106 back on there. So 106, oops, let's do this. I'll go up and jump on this one. You guys can fix this one. I want to change this to a 3/4 pi. Okay, then insert 3 pi over 4, right? Alright, so how high off the ground will we be? We'd be about 180.95 feet off the ground. Okay? So once you understand that scaling property of taking that Ferris wheel and taking it from the unit circle and just blowing it up 106 times as big, we put the scale factor in there. It's just working with however many increments we had, which in this case we had 22 increments, didn't we? 2 pi, or increments in terms of 2 pi divided by 44, which is every pi over 22, isn't it? Every pi over 22. Okay, so that brings us to the end of these video notes. I hope the unit circle made a lot of sense to you. We'll try it out when we get to class, and we'll see. And again, you probably need to struggle through some of this just to make sure that you really, really get it. But it's a very important lesson. You're going to get really tired of making a lot of little circles and drawing little pluses and minuses on there. You might even wear that card out. I hope you do, because that means that you're really using it a lot to your benefit.